Hi, and good day. Welcome to Supermicro's 5G Live with our guests T-Systems and Intel. My name is Jeff Sharpe, Director of 5G and IoT Embedded Solutions, and we have set up a very interesting session with our partners T-Systems and Intel. Our topic is focused on T-Systems' offering called EdgAIR. This is an industry-leading edge-based technology focusing on delivering applications using a wide range of software and hardware technologies. This session will be focused on the complexities of implementing and managing edge-based systems and how T-Systems, Intel, and Supermicro have partnered together to deliver some of the world's leading best platforms. Joining me today from T-Systems is Mitja Martini, Senior Technical Consultant for Edge Computing, and Michael Holzerland, Senior Sales Director at Intel. So let's start off with a short video on the collaboration between T-Systems, Intel, and Supermicro. Then Mitja will provide an overview of EdgAIR, and following his presentation, we'll have a Q&A session. So let's get started.
Edge computing brings computation and data storage closer to the location where it's generated in order to reduce latency, maintain network reliability, save bandwidth, and comply with the data security regulations. We recently unveiled EdgAIR, an edge computing platform that delivers low latency for IoT applications in enterprise facilities. This enables companies to use innovative, real-time applications in production, logistics, and retail, and includes automated guided vehicles and augmented and full virtual reality. The EdgAIR platform works directly on site. This means that the data is not sent to a central data center or the cloud. When we looked at the broad portfolio that Supermicro had, from edge to the cloud, we found that very compelling, and that's why we picked Supermicro hardware. We deployed a rack of Supermicro edge compute and storage servers running Intel Xeon D processors and N3000 FPGA accelerator cards. The evaluation has been running well in our lab.
Supermicro, along with Intel and our key software vendors, are working closely together with T-Systems, not just as a supplier, but as a critical partner delivering latest platform technologies, enabling high available software infrastructure.
We are extremely pleased with the performance and feel this can have the potential for widespread deployment.
Intel is looking forward to working with Supermicro and T-Systems to deliver compelling, optimized edge solutions for the marketplace.
Learn more at supermicro.com/5G.
Hello and welcome to my session about EdgAIR, the enterprise edge computing offering of T-Systems. I'm Meteor Martini. I'm a senior technical consultant at T-Systems with a focus on edge computing. Our view on edge computing starts with the data center or the public cloud. Usually, the center of your network is the most efficient place to run your workloads. But there are some applications which simply cannot run at the center, and this is where edge computing comes into play. We see four main drivers to the edge. The first is latency. This is a hard fact and basically the main driver. The second is bandwidth. This is often a soft fact, like you can decide which workload to run at the center or which workload to run at the edge, but often it is more economical to run certain kinds of applications at the edge. Next is security. This is actually two aspects for us. The first is data privacy. This is what maybe everybody thinks about when thinking about security at the edge. But the second for us is also resiliency. Using edge computing, you can make aspects of your applications more resilient to failure. Last but not least is connectivity. Edge computing helps to improve the connectivity between devices and from devices to the cloud. 5G brings three exciting enhancements to cellular communications. First, enhanced mobile broadband. This is about the high data rates and the large bandwidth. Applications benefiting from it are big data and edge analytics and all kinds of media applications, such as ultra-high definition video or 3D video. Next is ultra-reliable and low-latency communications. Here you need high reliability and low latency across all systems. Applications benefiting from it are autonomous vehicles, drones, and next-generation industrial automation. Finally, we see massive machine-type communication. Here you have a large density of applications or devices in the field and with a large coverage. Applications benefiting from it are smart cities and smart buildings. Today, we see the highest demand in ultra-reliable and low-latency communications. Therefore, for us as edge computing, low latency and high reliability as well as high bandwidth are top priorities for our campus edge computing offering. This slide summarizes what we think are key capabilities of edge computing. I already mentioned low latency, high reliability, and high bandwidth. What I want to highlight in addition to that is that we think edge computing shall support fast innovation. For this, we rely on our edge PaaS offerings that we create based on container and IoT edge runtimes. The EdgAIR platform is delivered in two different stacks. The first is Kubernetes. With it, you can run pure container workloads on a standard upstream Kubernetes system. We deploy and manage the Kubernetes for you on a single node or in a cluster at the edge sites. And you can use standard Kubernetes tools such as Helm 2 and 3 to deploy and manage applications on top of it. The second stack is based on OpenStack. With it, you can run mixed workloads with virtual machines, bare metal servers, and containers. Our OpenStack solution is based on Wind River Cloud Platform. This gives you a self-sufficient OpenStack cluster at each edge location. OpenStack gives you a single API for compute, storage, and networking, and a strong separation for the workloads, including multi-tenancy. GPU and FPGAs are supported as well, and you can get real-time Linux and real-time KVM nodes in addition to hardware-accelerated networking. We deliver EdgAIR environments in 4 different deployment options: embedded, simplex, duplex, and frame. Embedded is our smallest setup and geared towards Kubernetes. Here we deploy and manage a fleet of edge nodes in a way that is inspired by how embedded systems are managed. Simplex, duplex, and frame are capable to run both Kubernetes and OpenStack. With simplex and duplex, you get a hyper-converged OpenStack cloud with compute, storage, and networking services running on top of just 1 or 2 servers. The Frame edition uses role-specific servers and can scale up to 100 compute nodes and a petabyte of storage. All these deployment options can be combined to a distributed edge cloud. Within this edge cloud, each compute environment is self-sufficient and provides all of its services even in case of a network interruption. A central controller is just used for efficient management. On the hardware level, our objective was to deliver self-sufficient OpenStack clouds to the edge in small packages, especially with low power consumption. We based our solution for this on the Intel Xeon D reference architecture for edge computing and selected Supermicro as one of our vendors. Our bread and butter system from Supermicro is the 1019D. We use it in hyperconverged setups and as compute and controller nodes in the Frame solution. Another Xeon D system we rely on is the 5019D. We use it for management servers, for example. For the storage nodes in the Frame solution, we use the 6029P. An example deployment is at Osram. Here, an indoor autonomous guided vehicle, short AGV, transports goods across the factory. The localization and mapping algorithm is running on the edge, together with other applications. The robots communicate with the edge over a cellular campus network. This was, by the way, the first campus network installation in Germany. We run the edge computing platform in a duplex setup with two hyper-converged nodes with Supermicro 1019D servers. What we like about Supermicro is at first its comprehensive IoT and edge computing offering. You get a lot of different systems and very special ones too, such as the IP65 auto edge system that can be mounted on a pole. Supermicro systems are also quite easy to integrate. For example, we can use the same components in different chassis. This means we only need to onboard a configuration once, but can deploy it in multiple form factors. Supermicro is, in our experience, also quick in adopting new technologies. And last but not least, Supermicro also has an attractive global services offering. For us, the regional coverage is very important. What is also interesting to us is the supporting services with initial deployment, such as preloading and platform software integration. In this session, I focused very much on the IIS layer of the services. But this is only part of the picture. You can buy edge managed services from T-Systems on all layers. On the SaaS layer, we build turnkey solutions for the edge. Edge application operation means we play the ops part in your DevOps teams and run the applications on the edge 24/7. On the PaaS layer, we manage Kubernetes-based PaaS solutions such as OpenShift on the edge and also IoT edge runtimes. Managed infrastructure means we run your virtualized infrastructures on top of the basic edge computing platform. This is a good fit for applications you manage yourself or for appliances that are managed by a software vendor. Thank you very much for your attention. I am now happy to answer your questions. And if you are interested in T-Systems edge computing services, please drop me a mail or connect with me on LinkedIn.
Mitja, awesome.
Yeah, oh, sorry.
That was awesome. And thanks for that great introduction of the T-Systems EdgAIR system. It's pretty impressive. And I wanted to kind of do a little panel session between Michael and Mitja and myself, talk a little bit about EdgAIR. And also, I wanted to let the audience know if you have questions as well for any three of us, please type that in your window and we'll be happy to answer at the end. So quickly, so Mitja, this question's for you. With the EdgAIR, what's the greatest motivation for it? It's a great product, it's a great introduction, especially edge-based technologies. And how are you kicking off of this initiative? What actually was the driving mechanism around that?
Yeah, we as T-Systems are part of Deutsche Telekom, and Telekom has had already the 5G campus network initiative going on last year. And last year, almost exactly a year ago, Thomas Weber, which you saw in the video we just have seen, has been appointed the head of the Edge tribe of T-Systems. And edge computing for us was really from the get-go meant as a part of the 5G campus network offering from Deutsche Telekom. So that was how it was kicked off, and we already had some kind of backlog actually. There were projects going on. We had first customers, and we had really a very short time frame where we had to deliver the edge computing solution. So that was how it got us started, and it all started actually with the 5G campus network offering of Deutsche Telekom.
All right, thank you. And both Mitja and Michael, so on the collaboration, some of the efforts. So I remember our first meeting, I think it was like a November time period there in Berlin, very impressed with what you guys were doing. But with this collaboration between us, Michael from an Intel, what kind of was really kind of the kickstart of this?
So when you look into edge computing and edge networking, so this is one of the current really focus areas, what we see from our customers, is it in the cloud computing or even then with the telcos. So it was, as Mitja mentioned, so it was great as T-Systems reached out to us here, the local Intel Deutsche Telekom T-Systems team, and asked, hey, for our point of view on this leading edge topic, edge computing, right? And especially under the umbrella, when you think about edge computing and ask 10 people, so you get eight different opinions and 8 different then answers to one question. It's a bit like cloud computing 5 years ago. So we started with the first conversation on that topic, and we came over so that a series of workshops make sense with experts here from both sides, from T-Systems and from Intel, to get this buzzwords to an real topic, right? So real edge computing then topic. So we came over, hey, okay, after this series of workshops and conversations, and I guess we started in April, right, Mitja? So relatively early. And so after we agreed to this edge computing, on the paper, the logical next step was then for us to probe this, so to get this to a real then test. And so we went then forward in our proof of concept in the pilot, and especially then with all this leading edge then technologies, is it from Xeon D, so the hardened systems, and also the power of Xeon plus then FPGA. So this designed to bring this to real. And we were looking into the market. So which players are there, right? Who's addressing the topic edge computing? And it was not easy to find. So we got a few names, right, Mitja? And at the end, so we came over to Supermicro. And Supermicro now have established themselves as a really very reliable partner for this topic, edge computing. So when we start with that went really very smoothly. So the communication was always clear and open. And also it was going really fast forward because T-Systems, like many times, had here already pressure with customers behind. And so the pilot to prove what we have developed on the paper, then in this then proof of concept went really very fast forward. And so also the portfolio was a very, very good fit then for this approach.
No. And speaking of paperwork, actually we did the architecture on paper at first, and then really as soon as we decided on the basic architecture, and we said, okay, we knew we were going with Supermicro. We have been looking at a few vendors, but then that actually to get this from paper to actual proof of concept in our test lab in Bonn, where we also test our 5G networking, was really very fast, actually, and it was really a very good cooperation. And the actual paperwork to get the contracts done, I think, have been done in November also.
It took longer to get the hardware.
But it was really a very open and very good collaboration and very trustful relationship also from our point of view.
Yeah, absolutely. But it's also real hands-on. So that was also important. So in the lab in Bonn, so we had really hands-on then of the engineers from then all 3 parties. From Supermicro and we as Intel, we did the installation on site in the lab, and then T-Systems came to install the software stack what we have before then developed. So it was also great to see to bring this to real, right? So besides just paperwork.
And what I liked about that initial engagement too was, we had a huge table. Thomas, Michi, you were there. We had, both Supermicro, Intel, and T-Systems all around the table, and we were whiteboarding. We were kind of going through use cases, workload allocations. We were bringing things to the table. Intel was bringing to the table, and you guys were as well. So I thought it was a great initial kickoff. And as we're putting this stuff in your lab, we're seeing that it's coming to fruition. So and also in the atmosphere as well.
quick question for you guys on around that collaboration. You know, from an Intel perspective, again, Michael, you know, you were talking a little bit about FPGAs, you were talking a little bit about, you know, some of the higher end Xeons. Where do you see that going within EdgAIR and Intel and Supermicro? Do you see any you know, FPGA work that's going to happen, maybe even OpenVINO or other areas that that we're collaborating on?
Yeah, so absolutely. So as said, so edge computing is really a new topic, right? And to bring this then to real, so we are very happy to support here our partner, T-Systems, then to bring this to a real product. And especially when you think about here Germany, and Germany is very well known for our industry, right? And we were looking then into this target of the EdgAIR for industry edge computing. So we found that this is a very, very good approach, and T-Systems is here one of the leading system integrators in the German market. So we were super happy so that T-Systems came to us and that we were able then to bring in then our experience, then what is really a good fit for edge computing, especially under the conditions of the industry, right? So this is not a standard data center. So we talk about areas where telco racks. So from the size of the servers, this must be special, so short than racks of the servers. But also there's no cooling in. So really this must be robust systems. But on the other hand, they must be powerful because we want to do real computing and not just then collecting data then here on the edge computing. And this in combination with our Xeon D, so hardened then systems plus the Intel FPGAs and then an optimized stack, for example, then for big data analytics. And so then these components and ingredients then came together in this EdgAIR approach. And we are still super happy then to support T-Systems in this rollout, then, and especially with the target of the industry here in Germany.
And actually the system that was a bit challenging, because we all come from a data center perspective, basically, more than the IoT or the small part of it. And yeah, we were a bit unsure if the performance was sufficient and in such a small package. But actually, we were very satisfied. It was great. You have with the system on chip design, you have a very good network performance built in already. You have many CPU cores doing the workload chugging around nicely, and you can expand it with the extra cards as well. Still, yeah, and it is not only small footprint, but also you have a higher range of temperatures you can operate in, and that's really paying. And later, currently, we are not at this point, with, for example, smart cities. But I think we go also outdoor, and this is where. The perspective on this IP65 system I already mentioned is also very interesting to us. So that's really
a quick question for you. You know, we're talking about IP65. We're talking about outdoor conditions, the hardness, the temperature ranges at this, especially in Germany. I mean, you have extreme cold temperatures in the winter and nice warm temperatures in the summer. But as you're deploying these systems, do you see any major challenges that as a team we're trying to overcome with the EdgAIR program during your deployment phase?
Yeah, there are always small hiccups, like driver issues or compatibilities, but it was really quickly solved together also with our software partner, Wind River in this case, and actually that it is very standardized helped us a lot. So we really had very few issues with this driver stuff, and we were actually astonished that it was so easy. And it is also not a small feat, I think, to put a full complete OpenStack cloud at the edge. And it runs very well, yeah, and actually, and that was yeah, astonishing to us. And we did also test with larger systems, and found out, okay, yeah, if you have the cooling, if you have the space, we could also use the larger systems, but it runs very well actually on these small systems, and that was very, yeah. Also a bit astonishing to us, coming from the data center backend background.
But these are really Xeons, right? So it's
Xeon D.
It's a hardened system, but at the end it's a Xeon, so with the full performance, so that's the beauty. And yeah, the IP65 is a good extension then to the design of then the Xeon D-based Supermicro systems. So when they are running inside then the telco racks, on-prem, in the industry, and then there are special cases, right, for outdoor, and you have to provide then outdoor capabilities of edge computing, especially on a large campus when this is a huge customer, and then you have to provide then edge computing really completely outside. So therefore, the IP65 is really a very nice fit with all these additional systems. Is it cooling? Is it heating? So it completes at the end then this portfolio, especially under these conditions of edge computing.
Yeah, and also indoors, it's the same. Yeah, often you in the factory floor you don't have any space left. Yeah, so and it is great that we found a wall-mounted rack with 6-8 units, and yeah, a very constrained power budget. And we can really fit a cluster, a duplex system, and even scale it a bit inside of this wall-mounted rack. So it's really a great, very small footprint, very much power, a lot of power right at the factory floor. So it's really interesting for us, and a great solution for us also.
So Michael and Misha, we've got some good questions coming in from the audience. We have about 4 minutes left, so let's kind of cover a few of these great questions. One of them is coming in saying, what is your physical deployment strategy for EdgAIR? Is everything going to be on pole servers, or are you employing both multiple physical deployment strategies, not just pole but in cabinet?
Yeah, that's one colleague of mine always called it the curse of the edge. Yeah, the edge is different every time, basically. And especially with the environmental conditions and the networking. And so we made sure that we are capable to run in many different environments, and we have I only showed you the hardware or the deployment options, but we also have various rack deployment options. I mentioned this the outdoor, of course, but the wall-mounted rack. Then we have standard IT racks. Then we have racks which are locked and actually even protected against the environment, so with air filters in all kinds of sizes, and with cooling, without cooling, cooling with a splitter, and or with cooling on the side of the rack. And so today you have all the options, but you often see you should stay in quite a constrained power budget, but because if you go beyond a certain budget, you really explode in the stuff you have to get there. Also, uninterrupted power supplies, for example. It's all stacking up, and so that was really a key decision, and I think we made a great decision that we try to keep it small and have still all the capabilities, and that enables us to get this curse of the edge addressed, and get in various situations with our solution.
So we kind of squeeze in 2 more questions. We have about 2 more minutes.
Oh, sorry, I was a little bit.
This is awesome, by the way. So this is a really good one, and this is kind of where Supermicro can kind of come into play, is around power consumption. So what is the typical power consumption of the server and storage hardware that you'll see at a 5G edge site, whether it's at the radio tower or the consumer? And I know from a Supermicro perspective, we're heavily focused on low power consumption, because we know power is key for not just saving costs, but you don't want to put a tremendous amount of gear and just kilowatts and kilowatts of drawing power. So what's your thoughts on those power consumptions and some of the challenges?
Yeah, I cannot tell you the drawing power from the top of my mind. Yeah, it's much lower than the what's written on the PSUs. But usually you have to look at the PSUs because you the systems can draw in extreme cases that much, and even sometimes a bit more, and so you have to size the systems quite similar to what is written on the plates, and so we have the system, for example, the 1019D. In the top line it draws 500 watt, but much less in operation actually. But we size it or take into consideration that it can draw up to 500 watt. And in smaller packages with fewer cores, you can have 350 watt, and also a management system 350 watt, and you even can put FPGAs in still. Yeah, so you have enough headroom inside, and also equip it with enough storage and a lot of RAM, and still stay in your power envelope with that. I think that's really that's it.
And it's also the combination between the Xeon D. So it's also the combination between the CPU, so the system on chip, plus the FPGA that makes the system so powerful. And to stay then in these conditions, so in this edge conditions, what are different to a data center.
So, gentlemen, I'm going to have to close this down.
Oh, sorry.
Great session. We could go on for days. So this is awesome.
Sure.
I want to thank both Michael and Mitja for this great session on EdgAIR. And this video and presentations will be made online. And again, thank you for all your time. Great deployment, great partnership here with these three companies, and look forward to being successful with both of you. And again, thank you so much for doing this.
No, thank
you for
having me.
Today.
All right.
Thank you.
Stay safe. Thank you very much.
Yeah, stay safe.
Thank you.